Hello, ladies and gentlemen. Welcome to the second of three videos for Chapter 5, Section 2 of your McGraw-Hill Geometry Notes. This video, is going to cover the idea of a median in a triangle and talk about its properties as they relate to the point of concurrency of the three medians of any triangle. So, median is a line segment in a triangle which connects a vertex, i.e. one of the corners of the triangle, one of the 3 points of the triangle, to the midpoint of the opposite side. Okay, so if we look at the first triangle here, we can tell by the markings that M is the midpoint of side AC because we have these congruence markings indicating that AM and MC are congruent. So if we connect vertex B to the midpoint of AC, that line segment, MB, is a median of triangle ABC. It connects a vertex B to the midpoint of the opposite side, AC. Same thing over here. N is the midpoint of side DE as marked. The two marks and the two marks indicate that N is exactly in the middle. F is a vertex. So if we draw a line segment that connects N to F, we have drawn a median. Okay, so NF is a median of triangle DEF. Now, there are three vertices, there are three midpoints, so there are three line segments connecting a vertex to a midpoint, which means there are three medians in a triangle, just like there were three altitudes, just like there were three perpendicular bisectors, just like there were three angle bisectors. Okay, they come in threes. That's what triangles are. They have three of everything, pretty much. Okay, so if we drew all three medians in a triangle, they come together at a single point as well. They are concurrent, which gives us another vocabulary word here, the centroid. Did I miss any vocab words on that previous slide? I guess I did. Median is a vocab word, so it should be highlighted. Okay, so the three medians in any triangle, they are concurrent. They also come together at a single point. The point of concurrency of the three medians in a triangle is known as the centroid. It's worth noting that the centroid will always be inside of the triangle. And we can tell this is the centroid without being told that these are medians, because we should be able to recognize that AZ is a median. A is vertex, Z is a midpoint. If we connect a vertex to the opposite midpoint, that's a median. So, that's pretty much all we have for the vocab slide here. Now, the medians lead to one of the more mathematically popular theorems of this entire unit. Because of the versatility of it, leads us into the centroid theorem, which is going to be the last thing that we cover on this video. Okay, it'll be the last thing that we cover on this video, and then the next video will be made up entirely of examples of us doing the centroid theorem. So, the centroid theorem states that the centroid is always located 2/3 of the distance from the vertex to the midpoint. So, for example, okay, we're going to look at median AZ. Okay, we're going to look at median AZ. AZ contains point R. Okay, so our segment addition postulate tells us that AR plus RZ equals AZ. Notice that R is going to be exactly 2/3 of the way from A to Z. So what I'm saying is that if we consider the length of AZ, if we consider the length of AR, I'll make sure I say this right, that length is exactly 2/3 of the entire length of the median. So AR equals 2/3 of AZ. Now, that is not the only relationship that exists in this triangle, or on that median. Because if AR is 2/3 of the entire length, then, well, RZ would be exactly 1/3 of the entire length. Okay? Now, high school students tend to not be horribly great with fractions. So it's worth noting that these are equations where we are capable of clearing the fractions. So if we multiply both sides of that equation, by 3, we can clear those fractions out, and we can say that 3 times AR equals 2 times AZ, or we can say that 3 times RZ is AZ. Okay? There is actually a third relationship as well in this picture. Keep in mind that if AR is 2/3 of the length and RZ is 1/3 of the length, then there is a relationship that says that the big piece AR is equal to 2 times the little piece RZ. So the centroid theorem gives us these three relationships, numbered 1, 2, and 3. Now what we need to do is we need to generalize those into equations that we can actually use. Okay? But again, what this boils down to is we have a big piece, AR, that makes up 2/3 of the entire length of that line segment. And we have a little piece, RZ, that makes up 1/3 of that entire length. Okay? And then AZ would be the entire length of the line segment. So notice our three relationships here. Okay? We're going to generalize this. Okay? The centroid is dividing the median into two parts. Okay? If we consider any of those medians, but let's continue to look at AZ, we have the entire length, AZ, is equal to the big piece plus the little piece. That's our segment addition postulate from chapter 2. Okay, the whole length is equal to the big piece plus the little piece. That is one equation that we could use. Now, in addition to that, for every median, okay, we also have those other three relationships. 1, 2, 3. Okay, so there are three other equations that we could get based on medians here. We could say that 3 times the big piece is equal to 2 times the entire length. That was this first relationship, rewritten in general, would apply to any median form. Okay? We also have the relationship that 3 times the little piece is equal to the entire length. That is the second relationship. 3 times the little piece is equal to the entire length. And then the final relationship is that the big piece is equal to 2 times the little piece. These four relationships are the relationships that we are going to use to set up and solve problems based on the centroid theorem. We're not going to use the segment addition postulate very often, but it does come up and occasionally is easier to use than the other versions of the centroid theorem. Okay, that does it for this video. We have one final video which will show all of the examples of centroid theorem. Thank you very much for your time and attention. Please try to do a couple of those examples before you watch the next video. Thank you for your time.